Through its brands E1, Ferrara, KME, and Spartan Emergency Response, REV Fire Group partners closely with fire departments to build and deliver modular design, custom pumpers, and aerials, providing the right solutions at the right time for those who protect their communities.
Hi, Chris McClune here with Fire Apparatus and Emergency Equipment. Welcome to this edition of our podcast. Today, we're going to be talking about industrial fire apparatus. These trucks often are. I mean, if you've ever seen them, if you've gone to FDIC and you've seen some of the setups on these things, they're pretty impressive. Way beyond what we would need, ordinarily on a residential structure fire, but still, nonetheless, there could be features on them that would be appropriate for structural trucks. And with us to talk about this is Chief Rick Haase. He is the chief of the Staunton, Illinois Fire District. He's authored an article this month in our January issue on this same topic, but we're going to try to take a little bit more of a deeper dive into that today. So, Rick, thank you very much for joining me today to talk about these things. Before we jump into the industrial rigs, can you just tell me a little bit about yourself, your fire service career, and where you're at now?
Sure. So I've been with the Staunton Fire Protection District now for 42 years, and I've been the chief there for the last 29 years. That's kind of my municipal side. Actually, in the industrial world, I worked for the Phillips 66 Wood River Refinery. Actually worked there at the refinery for 39 years, and I was the fire chief at the refinery for my last 33 years. I retired from the refinery about 2 years ago, but I'm still involved from the industrial perspective, do some consulting work. I have a little consulting company, and along with that, I've done some stuff with FDIC and a couple of other companies, doing some industrial training and some industrial consulting. So still involved involved a little bit more in the mutual aid world. I'm on a regional hazmat team and a regional incident management.
So obviously you've had a chance to see quite a few rigs on both sides of what we're going to be talking about today. And that's where I'd like to start. Really, when it comes down to it, when we're looking at, an industrial pumper and a municipal pumper, like a traditional, structural fire pumper, what are some of the major differences between the two of them, just on the surface before we even dive into things?
I think probably the two or three biggest differences that you're going to see. First is usually pumping capacity. Most of your bigger industrial rigs are going to have a larger pump than what most municipalities are used to. So that's probably number one. Number two, probably from the discharge perspective, the size of the monitors that are on the truck and the number of monitors. And we're going to be talking about that a little bit later. And then last thing is probably foam systems. It's pretty common, especially when they're using these industrial rigs in the petrochemical world, that they're going to have some type of fixed foam system on them. So that's probably the three biggest things that kind of differentiate the industrial rigs from your typical municipal.
When you're talking about that, when we're talking about using foam, are the foam cells on those trucks usually substantially larger than what we're going to find on the more municipal rigs?
Yeah, and depending on the organization, I mean, a lot of organizations don't even carry water. So their foam tank, could be 1,000 gallons, 1,500 gallons, or even more depending on the situation. Reason being is a lot of these large industries, your big refineries, your big chemical plants, they have in-house what we're going to refer to as fire water systems. So they're dedicated firefighting water systems that are in the plant. Significant, it was nothing for me to pull up to a manifold at the refinery that I worked at that had 6-inch discharges off of it coming off a 16-inch main. So I could get a flow rate of 7,500 GPM off that manifold. So with that kind of water, the need for a water tank, especially when you're doing high flow operations, the water tank was kind of a waste of space on your industrial rigs.
So we kind of covered where I wanted to go next, but I'm sure there's more. What design changes need to be made to accommodate the amount of water an industrial fire apparatus is expected to move? I mean, you talked about the discharges, you talked about the intakes, you talked about the pump size. I don't know if there's more specifics you can get into on those things, but there also have to be some other things as well.
Yeah, so when we look at it first, it's the big pump, and in today's world, these pumps are getting large in size, so they're eating up a large area of the part of that truck. One thing that we're seeing now with a lot of the larger industrial trucks, they're going more to the rear mount pumps. And that's because of the size of the pump that we're seeing and how much room it's taking up. So, rear mount on a lot of these bigger trucks is becoming commonplace. When we look at these large intake manifolds and discharge manifolds, the literal size of these things, and then to be able to get in to work on them, I mean, lots of panels that are removable so we can, and I mean, I've seen them where I could literally stand inside some of these things to be able to access some of the different components to be able to get to them. Naturally, with that and the amount of water that we're flowing, they're going to all electric valve systems. Trying to use a manual valve system when you're talking about high pressures coming off of the hydrant systems in these things, they're just not practical anymore. But with that, very important that, we always looked at the place that I worked was what type of manual or backup system does it have? Because there could be that time when that valve fails or something goes wrong, but you still need to pump the truck. So, what do I need? What type of speed wrench or whatever can I put on there to still open these big electric valves? Another part of the piping system that we look at is, what's it made of? When we talk about foam, that was, foam technology continues to change. Now we're going to fluorine-free foam, and, the whole chemistry of what type of metallurgy am I going to use on the piping systems is even coming into play. So, people are looking at that. And then, of course, large scale, where we used to use in, some of the municipal pumpers, they use the flexible hose type systems. Well, when we're using these high pressure systems, these high volume systems, now we're going to stainless steel braided hoses, which again, don't have quite the flexibility of some of these old rubber systems. So that again eats up some of that space that we're looking at. And then of course, the whole piping system and the whole configuration that we use, we have to take into account if we do have a fixed foam system on that pump, what type of considerations do we need? Usually when you have your foam systems, you have to have, quote, some minimum straight run characteristics within the piping for the foam systems to work correctly. So with that, okay, how much of that straight run do I need to have in place to be able for the foam system to work correctly? And of course, usually in the big industrial pumpers, we are proportioning every discharge on the truck. Mm-hmm. So lots of moving parts.
When you talk about those straight runs, when again, I'm thinking on, I think municipally because, that's where I'm at. But we're always, in the internal plumbing on our pumpers, we're always trying to, with some of the designs today, when you're really smushing that truck down a bit, you need a lot of bends. Anytime you have a bend, you're going to have friction loss. And so you just mentioned that straight run, and obviously, on the trucks that we're designing, for my fire company, for example, we're trying to limit the number of bends we have, particularly like the front intake. It's going to go down, it's going to have to come back up. But the back, the rear intake, we're trying to get those straight runs there too. Is there for water? Is there as much of a concern about the friction loss? Because we're talking about such large discharges. Like when you think about 5-inch hose versus 2.5-inch hose, there's the friction loss is almost negligible between, a 5 inch and a 2.5 inch. When you go to the 5 inch, it's just so low. Is that something that you're worried about on the municipal, or I'm sorry, on the industrial side?
So one thing that we need to keep in mind too, and a lot of people don't realize this, but when we start putting those foam systems on those trucks, the foam proportioning systems that we install, they're for a certain size piping, and
Okay.
they'll allow flow rates between X GPM and X GPM. So when I do that, I have to understand. Okay, hey, I'm going to be proportioning, and this is going to be a 6-inch discharge. Well, I need to make sure that my piping supports the proportioning for a 6-inch discharge. Knowing that, especially on some of the older systems that were out there, that if I quote, I'll just make it a big one, make them all as large as I could. But if I only wanted to proportion, at 250 or 500 GPM, I may be oversized, and now I'm not going to make good foam. With some of the newer systems that are out there, doesn't come into play as much. But something to consider depending on the foam system that you're using, and of course that varies by manufacturer. So you really have to be working closely with that company that you're going to be installing that system on your truck. Because years ago you only had quote 1 or 2 players in the foam system. Now we're seeing a lot of different companies, and each one's a little bit different on how they work and to what extent they will proportion and through the different size piping. Then naturally, when we're talking about just general high flow operations, the bends probably don't come into play quite as much. It's really from the foam side.
Okay.
Usually what you're going to see on most of the industrial trucks, though, is they're going to try to oversize that piping whenever possible on both intake and discharge to maximize flow rates.
We've been talking about volume of water so far, and it occurs to me as and just in I was at a fire in it's coming up on almost a year ago now, that was at an industrial facility, and we were we deployed large diameter task forces and stuff like that to get us the water that we needed, but we also needed reach. So like at an industrial fire, like are as someone who served on one of those brigades, are you looking for volume, reach, or some kind of happy medium for both?
Yes and yes. So with that's why we're going to high flow streams on these trucks. So that's why you're seeing usually on your industrial trucks, probably the minimum monitor size you're going to see is 2,500. That's probably absolute minimum.
Okay.
And then, matter of fact, with a lot of the newer trucks, what we're seeing is dual 2,500s off the rear, one on each side. And then center of the truck, we're probably seeing, a 5, 6, maybe even a 8,000 GPM gun. And reason being is 2 things when we're fighting these large industrial fires. One is just like, we don't want our PPE, the distance we are from the fire is providing us that safety aspect. So, if I'm using a large scale stream, I can be 300, 400, 450 feet away with that 9,000 GPM stream, and I'm providing safety for my folks. The other big thing that a lot of people don't recognize is when we're fighting these large scale industrial fires, if we are trying to fight that fire with 1,000 or a 2,000 GPM stream, that thermal updraft from that fire is just tearing that stream apart. And we're not applying an effective water stream to that fire. So getting that 2,500, 3,000, 4,000 or higher stream on to that fire is going to eat up those BTUs off that fire. And we're not going to be turning that stream into vaporizing it into steam. We're going to hold it together because it's mass density. So we're actually hitting the fire with that water and doing good cooling.
You just mentioned all those rig mounted monitors that we have, but there are also, and I'm assuming that there are those who might not know, but there are aerial fire apparatus, aerial industrial fire apparatus as well available. I can't personally, like, I've never done it, so but I can't picture those kind of high flows coming through through a pre-piped waterway on an aerial, but maybe it happens. But describe some of those the aerial fire apparatus that we might see and their typical capabilities.
So the industrial aerials that we see out there, usually about 3 different configurations is what we're seeing. Straight sticks for a while were very common. The nice thing about the straight sticks, certain manufacturers are out there. They'll use a larger waterway on those, and with that, you're going to get a higher volume. The use of an inverted waterway was very common. So as it goes up, the waterway gets bigger, so it overcomes that friction loss. So with that, high volume monitor up there was great. The other thing with those sticks, they typically weren't made to climb while the monitor was operating. So it was all remote controlled monitors again, so you get the high flow rates on them. And that used to be the maximizing the aerial. We've seen it in the past. Now it's kind of making another charge back into the industry is the articulating waterways. They're using the concrete pump version of a aerial. And, I've seen those, 4,500, 6,000 GPM with an articulation on them. Again, with those typically don't allow you to put anybody up on the waterway. So it's a complete remote control. But then there are some organizations that are still using the platforms. The platforms are there for rescue operations, especially high angle type stuff. A lot of your industrial facilities may get into, high angle emergencies. So that's something else to consider. When you do put that platform up there, though, a lot of times it will cut back on your flow rate capabilities because of how much weight you're hanging out there off the end of the ladder. Remember, all of that water and the back pressure that you're seeing is going to limit that once you put that platform on the end of that ladder.
What are, I want to talk a little bit about, municipalities like mine, like the one I was talking about. I'm a volunteer fire company, but we had a pretty substantial manufacturing facility in our first two. I want to talk about, how local departments can assist with the industrial fire brigades. But at the same time, but before I do that, could you just talk about any trends that you have identified over the years or more recently in industrial fire apparatus? It seems to me that there are more available. I see a lot of the manufacturers really kind of diving into trying to develop rigs specifically for that. But beyond that, like the rigs that you see coming off the lines these days, are there any trends that stand out to you?
Yeah, so there's a number of things that we're seeing that's changing over on the industrial rigs. Like I said a few minutes ago, the first thing is the multiple monitors. That's kind of a big thing. With that multiple monitor system, though, one thing that we're seeing a lot is the ones that are off the back tailboard areas, those fixed monitors. They're setting those things up with a kind of a multifunction valve system in the back. So one, they can be fed off of the pump. Two, we can actually take that and we can put in a line from another apparatus into that, block it off from the main pump on the truck, and now be feeding that monitor from another source, which is kind of neat, especially if we're looking at maybe we've maximized already how much water we're pushing out because we're using that 9,000 GPM gun. Now we may be able to supplement that by even using a municipal pumper to feed those back too. So that's something that we see a little bit different. Another thing that we're seeing in the industrial world is, and it's just because of how much flow we're trying to get, is trying to get bigger hose beds on the trucks. A lot of the industrial trucks, we're seeing 6-inch hose being the minimum that they're using from a supply hose standpoint. They're going to 6, they're going to 7.25, they're going to 8, they're going to 10. So once you get into that size hose, you got to come into, kind of a new realm of what your hose bed's going to look like. Back in our trucks at the refinery where I work, we laid dual 5s to try to increase that flow rate. So all of our hose beds were set up to lay dual 5s. The other thing that we're seeing is pre-connected portable monitors. Very common now. So, whether it be, your blitz fire type monitors, or even, a 1250 that's coming off a 5-inch that's literally pre-connected off the back end of the truck to be able to get that quick setup and get those high flow rates at more of a distance from the apparatus if needed. So that's in play. And then, of course, any ancillary, depending on the type of industry, seeing some apparatus are putting small dry chem systems on them. So that, something that I've seen a little bit more of here recently. And then just all of the support equipment. And it depends, what's the purpose of that truck, or, how is that organization set up? I've seen some. We had a rescue engine, but it was a rescue foam engine. So we carried a full complement of. We had a hydraulic rescue tool. We had confined space equipment. We had rope rescue equipment, but it was still set up to function as a foam apparatus as well. So, and then of course, for departments that are doing, quote, structural firefighting, they still need to be carrying that equipment that if they're doing actual structural. I mean, a lot of large scale refineries and petrochemical plants, they have buildings, but really their trucks are set up for, quote, process unit and or storage tank firefighting. And they really don't carry a lot of the a lot of the structural firefighting equipment.
I mentioned a minute ago about, municipal departments that have these facilities in their first due. And not every facility will have its own fleet of trucks, to get started. So sometimes we're almost, behind the 8 ball even more because of, the fact that, nothing can be done until we get there. And setting up for something like this does take a bit of time. But, how can departments that have a facility in their first due that has its own, fleet of industrial rigs, how do they help? How do they support that operation? Because when you think about it, there aren't municipal rigs are not carrying 10-inch hose, so how are they? Is it just staffing at that point, or are they getting into the water supply operation?
We actually had, so we were a little unique. My refinery was literally, we had no other industry around us. So once we started going to mutual aid, all of our box alarm companies that were coming in, they were all municipal departments. So with that, we clearly identified what apparatus we wanted coming in.
Okay.
And the way that we did that was we put some minimum requirements. The minimum requirement was, hey, we want a minimum of a 1,500 GPM pump. We really wanted more than that if it was available, but minimum of 1,500 GPM pump, a minimum of 1,000 feet of 5-inch hose in the hose bed. So those were minimums. Around us, we were seeing things change. A lot of the departments that were close to us, because they recognized after they came, we would have them come in and train with us on an annual basis. And we did some high volume water supply stuff with them. And they're like, wow, having these big guns really make them effective, even from the structural firefighting standpoint. Okay. So what we were seeing is a lot of the departments around us started going to 2,000 and 2,500 GPM deck guns. That was becoming common. They were going to 1, and in some cases 2 LDH discharges on those trucks. And then literally understanding that I can make that 1,500 GPM pumper inside my facility where I have a water supply that, our base level pressure on our hydrant system was 150. And
Oh,
then
wow.
when we went to an actual fire in the facility, it went to 175. So I could take that 1500 GPM pumper, I could make it pump 2500 GPM, or in some cases pushing 3000, depending on what type of plumbing they had on that truck. So understand, how do I maximize water into these municipal pumpers, and how do I maximize water out? And a lot of people don't even think about this, but we were maximizing water out by, if they had three 2.5s off the passenger side of that truck, we'd put three short lengths of 3-inch hose into an LDH manifold put in backwards, and then up that to a 6 or 7.25-inch hose. And now, it's like having another LDH discharge right off the side of that truck. So it's understanding how to move big water. And for your big industries that understand that, they're going to work with those municipal departments to show them how to do that.
That's amazing. 175 pounds off a high. That's
So
not too bad.
that truck becomes a great big gate valve.
No kidding. Wow. When I guess the next couple of questions I have here are probably going to fall into that it depends answer. But what does a typical industrial fleet look like? I mean, is it two pumpers in an aerial, and one of the I don't know what you would call it. It's like a stake body truck almost, with a massive monitor on the back of it, kind of a deal. Like, can you give me an idea of what a fleet would look like?
Yeah. So first and foremost, it's probably one of the big things that come into play is what type of other industrial resources are in the area.
Okay.
If we were down in the Houston Ship Channel has a huge amount of industrial emergency response resources available. Because of that, some of the individual companies down there probably don't, quote, ramp up and have everything readily available, because they have so much industrial mutual aid available. Getting back to the facility where I worked, we were on an island. There was nobody else coming from an industrial perspective. So with that, we had to provide all the things that we needed. Probably the biggest thing that's going, if storage tank firefighting is going to be an issue, that's probably one of the biggest things that come into play, because I have to proportion enough foam to put out that largest tank in my facility. So, if I had that 300-foot tank and I need to be proportioning foam at 20,000 gallons a minute to put that tank out. Now, if I don't have mutual aid coming, how do I do that myself? Now, there's other ways other than industrial apparatus. I could have portable pumps, for example. Portable pumps are becoming very popular in the industrial world. So the big submersible pumps that are becoming quite common. But then there's the other, what I'm going to call relay pumps, that are also very popular. So, but in the typical, what you're going to see is, I'm going to say, bigger chemical plants, bigger refineries, usually a minimum of 2 pumpers. And with those, usually now you're seeing probably a 3000 GPM pump as being the minimum.
Okay.
And most of the time they're, a lot of them are even building them bigger. They've got 5,000 and 6,000 GPM pumps, but 3,000 is usually about the minimum that you see. An aerial is quite common, and usually with those, again, it's probably going to be at least a 3,000 GPM pump on those. Foam tanks are usually 1,000 gallons minimum. I mean, the aerial that I had at the refinery, we still had an 800-gallon foam tank on that truck, which was rather large considering the type of apparatus. A couple of the other ones that are, you're typically going to see some type of foam carrying system. And I'm not going to say foam tenders. We had 2 4,000 GPM foam tenders that we had. Now, some of them are using actually the tractor trailers that are actually just, tank trailers that 6,000 gallons of foam, and they may have some type of either a PTO pump and or an engine driven pump on it. But foam tenders are quite common to be able to get those large quantities of foam to the scene a lot quicker than 5-gallon buckets. So they're typically dealing with totes are usually the 275-gallon totes are usually the smallest ones that you're going to see. Some type of hazmat truck and or rescue truck. In some smaller facilities, that may be one and the same. In a larger facility, I mean, the facility I was at, because we were kind of self-sufficient, we had 26 apparatus and we had 14 trailers. So it was and 3 boats. So we were pretty large scale because of we were the 10th largest refinery in the U.S., 3,300 acres, included everything from processing units to a large dock facility on the Mississippi River. So you had to have the resources. Another thing that's quite common that we're seeing in a lot of industrial world are the quick attack trucks.
Okay.
So the quick attack trucks are those 1-ton, pickup trucks, 3/4-ton pickup trucks, utility bed trucks, and they're going to put, a couple of 1250 monitors or a 2500 or a 3000 GPM fixed monitor in the back. When we first started using them at the refinery years and years ago back in the 90s, we used to refer to them as disposable fire trucks because we would get the old pickup trucks from maintenance that they didn't want it anymore. And we said, we'll take them. And our theory was, hey, we'll give up a pickup truck rather than pulling a $500,000 foam engine back then up close and personal. We'll drive a quick attack truck right into the process unit if we had to, and get either capture on a source of a fire and or use it for exposure protection. So those quick attack trucks, we had 6 quick attack trucks at the refinery, and they were out. We actually issued them to our shift supervisors, and they drove them every day. So they were out in the plant, readily available for every incident that we had. And then specialty vehicles. I mean, some facilities actually have their own ambulances. We had an ambulance. We didn't transport off site, but we transported. Some facilities actually have full-blown transport ambulances inside the facility.
Okay. Now, with the quick attacks, are those kind of like you get it set up and then you don't rotate the monitor at all after that? Is that sort of like you get it set up and that's done? And because
yeah, I mean that's the typical. Usually with quick attack vehicles, we're doing one of 2 things. One is we're going to pull that vehicle in close, and if we have a fire that's coming from a source, we're going to try to capture that within a power cone to hold that source where it's at, so it's not spreading the fire. So using it for capture was quite common. Or the other thing would be exposure protection. So, hey, we had pressure vessels in the area that we want to keep cool. So we're going to get in there and use that. Now, we have used quick attack trucks, for example, storage tank firefighting, because we could get the quick attack trucks down into the tank dikes and a little bit closer to the actual tank in some cases, just because of configurations of how large the tank dike might be or something like that. So I'm not saying that we would never have somebody in the back of them, but usually it was, quote, set them and forget them. Now, one thing that we are seeing in the quick attack world is going to a lot more remote control monitors, which makes that a lot easier because now you use a radio controlled remote control monitor, and I can be standing 100, 200 feet away and still directing the stream as needed.
Is that when you do that, though, do you need to shut down everything going to it so you don't tip the truck or anything? Or
you have to realize the complexity and your center of gravity of the trucks, depending on the size of the monitor that you have in the back. Usually, most of our quick attack trucks were set up to shoot directly over the cab. That was the most stable point. So we could kind of go from edge of cab to edge of cab, but to go a straight 90 off the side of the vehicle, we would not typically do that. I will tell you, UTVs are not a good candidate for even. We tried one with a 1250 monitor mounted in the back, and it literally moved the UTV. There was not enough weight on that UTV. Gotcha. So you can't use a UTV for a quick attack. We found that out through some experimentation.
With those fleets, are they usually on I mean, I guess everybody kind of has a different replacement schedule, but I mean, like, do the industrial fleets have a majorly different replacement schedule than a municipal fleet would, or are there standards that govern when you need to retire an industrial rig?
So usually you're going to see that the requirements come from usually two different sources. One will be corporate standards, the Kinder Morgan versus the Phillips 66 versus the Mobil Exxon. Each one of the organizations typically have corporate standards that say, okay, we're only going to allow our apparatus to get to whatever it might be. I will tell you, in general, in the industrial world, it's, when we see, a lot of municipal trucks where they look at, 15, 20 years, you're probably looking at 20, 25 years in the industrial world, because they're not putting the mileage on those vehicles. I mean, they're within a fixed facility. I mean, our apparatus, they didn't see highway speed except when we took them out on the road test, when we did our regular truck checks. I mean, they, when they're in the refinery, they're never getting above 20 miles an hour. So a lot different there. The other one that you'll see is insurance requirements, because a lot of these companies, they have insurance requirements that they'll have. The insurance vendors come in and say, okay, we require to keep you insured. You're going to replace those apparatus on this frequency.
Okay. What about preventive maintenance? I mean, these rigs are not, they don't see as much in service time as a municipal rig would, getting around and, just with training. I guess would what does the preventive maintenance program look like for industrial rigs? And do they get most of their workouts during training?
Most definitely. They by far get most of their workout during trainings. So, but the, I guess from the standpoint of what type of preventive maintenance, it's going to be dependent on what type of staffing that facility has. I was lucky enough, the first 20 years that I was the fire chief, we had an all-volunteer response organization. So I was literally the only full-time person assigned to the fire station during my first 20 years, and I had an all-volunteer staff that came from inside the refinery. The last 15 years, I had paid personnel. So once we still had volunteers, so we had, quote, a combination staff of paid personnel and volunteers. But once we got to that point, our preventive maintenance looked much like what most fire departments, because that was part of the work of the paid guys. They did a lot more than what the actual municipal firefighter did with other work out in the refinery. But apparatus preventive maintenance was part of the process. Now, part of the problem with the preventive maintenance with the industrial rigs is going to be the foam systems. The foam systems require a lot of time to keep up, to keep them clean, understanding how they work, flushing them out after training, flushing them out after work, calibrating them, just like when you did annual pump tests, you did annual calibration of the foam systems as well. So there was added preventive maintenance that you saw as soon as you add that foam system to the truck.
Okay. Is there I probably should have asked this when we were talking about those large flows before, but is there almost like a baseline for how much water, like, right out of the gate, you want to be moving this much water for an industrial fire. Like what do your SOPs call for? Is it saying we want to be in place flowing 2,500 gallons a minute at least in, like X amount of time, or how's that work?
Yeah, so and that's going to be dependent on the hazards of the facilities. We had a standard, and our standard was we categorized our quote processing areas in 3 different categories: small hazard, medium hazard, high hazard. For a small hazard process unit, we wanted to be able to immediately get to a 2,500 GPM flow. So that was both with the apparatus and the water supply in that area had to support that. For a medium hazard type process area, we were looking at 5 to 7,500 GPM is what we were looking at for a medium hazard. So 2,500 to 5 was the low hazard, 2,500 to 7,500 for a medium hazard, over 7,500 and above for a what we called a high hazard process unit. I fought fires in the refinery where we were flowing within 45 minutes of the incident, we were flowing 15,000 gallons a minute. And that was all flowing off of the hydrant system in the refinery. So, understanding where do you get that water? How do you put out those hose lines? One thing that we used to support that, we had a hose tender. So we had a hose tender that carried 9,000 feet of LDH. So we laid triples of 7.25 off the back of that truck.
Pumping one of these rigs, is it that much different than you gotta know your flows. I mean, the lines coming in are going to be different, so there's different friction loss and things of that nature that go with any truck that you're pumping. But are there any major differences pumping an industrial rig versus a municipal rig, and what are some of the things that the pump operator has to be looking for if there are some differences?
Probably the biggest difference is, I'm still in the municipal world, and okay, I start that deck gun up and I'm flowing 1,000 gallons or 1,500 gallons a minute out of that deck gun. Okay, I understand that, but when I'm flowing that deck gun and it's flowing 5,000 gallons a minute, where's that water going? What's it hitting? Is there somebody out there that has the potential to get hit by a 5,000 GPM stream? I mean, so where's your people at? The distance that I'm throwing that. Now, with most municipal pumpers, when we throw that 1,000 GPM stream or that 1,500 GPM stream, and we throw it, maybe a couple of 100 feet, and now I've got this 5,000 GPM stream that I'm throwing the distance of a football field. What is it hitting out there when it's coming down? And then, of course, let's go to the opposite perspective, that I'm flowing foam, because if I'm flowing foam, I'm really hoping to hit it off of something to aspirate that foam anymore. So, can I hit it off the side of a vessel or something to get myself better foam? So with that, a lot of the municipal pumping operations, I'm actually using a 2-person team. One person that's operating the pump. The second person is my spotter, looking to where are those big streams going and what's happening when that stream, because that pump operator really doesn't have that perspective. Now, granted, you can have the radio controlled, monitors and everything else, but with everything going on, especially if he's proportioning foam and he needs to make sure that he doesn't run out of foam in the tank, and how am I going to resupply this foam engine or this foam aerial? All of that has to come into play. So in large scale operations, you may have 2 or 3 people that's actually working from a pump operating team perspective.
Well, Chief, I want to thank you for sitting down with me. This is this is kind of fascinating, just because of the volumes of water you're trying to move. And, if the audience ever gets a chance to look at one of these, especially some of the new ones that are coming out right now, they are some very impressive pieces of machinery, the industrial rigs that are coming out. But Before I let you go, do you have any general comments about industrial rigs? It could, just it could range from how to spec them, just other things that may have popped into your mind while we've been talking. And any general comments on that?
Yeah, first, I guess a couple of different things. First, in the industrial world, it's actually no different than where we're at in a lot of the municipal world. It's being manpower efficient with minimal number of people. I mean, in a lot of industrial facilities, you don't have, you know, just people sitting there waiting to go to fires. So, these industries are trying to run with minimal staffing as well. So, what can I do to make these apparatus as manpower efficient as possible? Remote control monitor systems, remote control valves, whatever it might be. So that's really important. The second thing is quality fire streams. In the municipal world, we use so many straight stream type nozzles on a lot of our operations, but in the industrial world, we are using, for the most part, with most of the petrochemical refinery operations, you're using fog patterns because you both need the reach and you need to be able to capture the fire. So having good quality nozzles to be able to do that is really important. I personally thought that we bought a big monitor on one of our newer apparatus. It had the flow rate that we were looking, but the pattern wasn't there. So after a couple of years, we actually ended up changing the nozzle portion of that truck out to get a better stream that we could control better. So that minimal staffing and understanding what we can do and what can't you do. The other thing that a lot of people don't think about in the industrial world is, can I get my truck there? So many people, hey, I want this great big foam pumper that's got, 2,500 gallons of foam and a 6,000 GPM pump and all of these different elements. And now this is a huge truck and I can't get it down 5 of the roads within the refinery, or it doesn't fit underneath the pipe rack. I've literally seen people spec out new trucks and they couldn't get it to certain parts of their facility because it didn't fit underneath one of the pipe racks. So you have to, as you design your trucks, kind of understand what you're looking for. And then, of course, the last thing is, what type of water supply is available? Do I have this unlimited water supply, or, am I required to use alternate water supplies? Do I have a bunch of lakes that surround it? The big one with that one that I've seen that has come back to haunt some people, some of these smaller terminals that have purchased industrial apparatus, they're still running off the city hydrant system. And in many cases, they're at the end of the main. So very minimal water. I mean, if you've got a 3,000 GPM pump and you got 1,000 GPM hydrant, you're not doing yourself a whole lot of good. So understanding, what are my capabilities and where's my water coming from is something you need to be thinking about.
It's almost like no different than a high risk building in your first due. You're still figuring out, what fire flow you're going to need, where you're going to find the water. It's just a different size truck.
Yep.
Well, Chief, thank you very much for sitting down with me today to talk about this. This is it's a topic that I haven't really covered in a podcast yet, so I really appreciate you taking some time out. If anyone has any questions for Chief Hazy or any to give to me to get over to him, I'm sure he'll welcome the questions. If there's a topic that on the industrial side that you'd like us to hit on, please let me know. I'm at chris.mcclune@clarionevents.com, or you can use the contact us link on our homepage at fireapparatus.com. Speaking of the homepage and the website, all of our podcasts are archived there. You can find them at www.fireapparatus.com/podcast. podcast. So again, my thanks to you, Chief, for sitting down with me today to talk about this. Don't forget, the Chief also he also authored an article in our January issue that if it has hit the mail stream, so you should be getting it soon, and it was on industrial fire apparatus as well. So make sure you take a look at that when you get your issue. So again, this has been Chris McClune with Fire Apparatus and Emergency Equipment. Have a good one and stay safe. Thanks again, Chief.
Thank you.